All right, I'm starting the recorder right now, and hmm, forgot about this one. Okay, it'll take a little bit of time to start this up, which may not be necessary, so we'll see. All right, so what we'll do today is we're going to talk about the quote unquote practice exam. I put air quotes around practice exam because this was the actual exam from last semester, from spring 2025. Um, but yours is not going to be exactly the same for sure. How much is similar, I do not know yet, okay, because I still have not come up with all the questions for your exam. But the scope of the exam is still the same. In other words, what I want to test about, what I'm trying to assess, will still be the same as what we see in this particular exam. So with that said, I'm going to open up the PDF, okay, because my router is still starting up, so that will take a while. All right, so we'll start with the instructions. Okay, the instructions are not going to change by too much. So we'll go ahead and read the instructions a little bit together. The first thing is it always kind of show you the date and the time when the exam is going to happen. The second one is always stating that the exam is individual, which means the score or the grade is going to reflect the individual person with the student ID indicated the performance of that particular person or the competency of that person. So that's pretty boilerplate for exams. The third one is something that you probably want to keep an eye on because you are allowed to bring as much material as you want on paper to the exam. So you can bring your own notes, assuming you have been taking notes. If you have been taking notes on a computer or a tablet, you will have to print it out first. Okay, so you cannot bring a computer or a tablet or a cell phone, for your notes. But you can certainly print anything out and bring a paper copy of everything that you want to bring. You can bring the reading material, the modules that I have written. Okay, that's perfectly fine. You can ask the GPT TA and give you a quick summary of each module and bring that along with you. That's perfectly okay as well. You can watch the video, okay, which is being recorded right now. Take a screenshot on anything that you think, okay, I think I might need to refer back to this one. Copy and paste it, print it out, and bring it with you. So basically, anything on paper is fine. You can even work with other people when you are working on the pieces of paper that you want to bring in. So you guys can collaborate with each other. You can find people who have taken this class before, okay, and ask those people, can you share your notes with me? You can bring those with you. The one thing that you cannot do is during the exam, I cannot let people exchange their notes. Okay, so that's the only one thing that we cannot do with your notes. Otherwise, you can bring anything in. You can collaborate with anyone. Um, yep. All right. The third one is do not share or discuss any part of the exam with anyone in class or otherwise until the next class meeting. That has to do with sometimes some people for for whatever reason cannot take the test on that day. So I don't want someone to accidentally quote unquote spill the beans to those people. Grading is based on explanation and steps. So if the question is asking you to show the steps, then you have to show the steps. Just giving me the final answer when the question asks you for steps is not going to give you a lot of points, if any. Okay, so if the question asks for an explanation, if the question asks for steps to show how to do something, you have to show the steps. All right. In an earlier part of the question, if the earlier part of a question is answered incorrectly, partial credit may be given to a later part. So let's just say a question has three parts, A, B, and C. You got part A kind of wrong, okay? But part B is consistent with part A, and then part C is consistent with part B. I can potentially give you partial credit for parts B and C, but that really depends on the question and how you answered it. So there's no guarantee, okay, but I will consider giving partial credit when part of the multi-part question is wrong, but the rest seem to be correct. Sufficient explanation is spelled out a little bit more. Okay, so in this case, a sufficient explanation is basically you have to show me that you have the knowledge, which are the definitions, and so on to start with, and then you show me step by step and say, okay, logically or mathematically, these are the steps that I need in order to arrive at the answer to the question. Okay, so that way I can see that you have the knowledge, you have the skills, and you know how to derive the answer. You can write the answer on the exam itself, which I usually give you a little bit of space to do it, but some people like to do it on a separate piece of paper just because it is lined or it's lined properly and so on. So if you're one of those people who prefer to use your own paper, that's okay too. Okay, bring your own pieces of paper with you, lined or in a grid, whatever format you prefer, and make sure that you write your name on those paper even before the exam. Okay, so this way you're not wasting time in the exam just to write down your name on those pieces of paper. Okay, so you can do everything ahead of time, so don't do it during the exam. I'm already telling you that all the questions will carry equal weight. So that means, the first thing I would do in my own exam is to do a quick scan of all the questions, all the way from page one to the very last page. Then I will kind of rank the questions and see which one seems to be the easiest for me. And I'll start with that one. Okay. Um, and I would time myself too. So I would look at the number of questions and I go like, okay, I'm going to allocate enough time so that I have almost an equal amount of time for each question. And I'll also make sure that I have a little bit of time left at the very end. So if I need to go back to an earlier question, I would have some time to review or to revise, one of the questions that seem to be a little bit tricky. So from that point, we are now moving on to some notation stuff. The notation stuff is nothing new, okay? In other words, this portion here is nothing new. It is really just a repetition of the symbols that we have been using in this class. Most of these have been introduced in on the first day of this class. So, but I just put it here just in case people go like, I have no idea what this symbol means. So instead of trying to answer those questions during the exam, I'm just, kind of, okay, let's have a repetition of all that stuff here so that people don't have to ask me during the exam. All right. So, are there any questions right now about just the instructions of the exam? No questions? All right. Then we're going to move on to the first question. So you have to read the question carefully. Okay, I try my best to describe what you need to do, but sometimes it may or may not get conveyed. In the following space, explain how to conclude the given statement on each line. The explanation on each line can only utilize statements, so each line is a statement in earlier steps. You cannot change the order of the explanation. You cannot say, okay, I'm going to reorder so that your 7 is and 5 are going to change places. Nope. So you have to maintain that sequence. If you are visual, you can use long addition subtraction table to visually aid your reasoning, which means on the side, okay, you can just kind of carry out or at least try to explain all the digits to in a long addition or subtraction, so that you can kind of keep track of, okay, positionally speaking, this bit is over here, because some people are more visual than others. Okay, so you can use that. Each line, oh, okay. However, I only score based on the following list of explanations. So the scratch paper, the diagram, the tables, the long addition or subtraction is useful to you, but I may not be using it for grading purposes. So what I'll be grading is based on each line can be explained by just statements already given or explained. Okay, and I will show you exactly what that means. And you can comma separate it, or if it is clear, that this is a number, this is another number, you don't necessarily have to comma separate, but I prefer to have a comma between all the numbers just so that it is clear that okay, this is one number, this is a number, and so on. Because otherwise, if somebody just write down 1 4, how do I know it is statement 1 and statement 4 as opposed to statement 14? Kind of depends on the spacing, right? Someone can say, "Oh, this should be enough spacing to separate the 1 and the 4. It should be pretty clear that I'm talking about statement 1 and statement 4." But when I see it, that may not be conveyed. Okay, I may see the spacing as looks like 14 to me. Okay, so I don't want to get into any ambiguation. So use a comma to separate. So if the question says use a comma to separate, please go ahead and use commas to separate the numbers. You do not need to use English to explain. However, please be complete and quote all but only the directly related statements leading to the concluded statement on each line. Since all the bit values are resolved, scoring is based on the proper explanation of the given statement on each line. An explanation in this case is basically what the previous paragraph is describing. All right. So at this point, I'm going to ask how many people gave it a try before today, or at least take a look at the question. Okay, very good. Okay, so once you have taken a look at least at the question of what it's asking, even if you did not give it a kind of like full effort attempt, at least you know what this is kind of asking you about. So I can tell you right away, anything that is saying, okay, no need to explain, this is given, that means exactly that. Okay, it is just given to you, and you don't question why. You don't have to question why it is the case. With some of these, you might recognize, and go like, oh, okay, I see how T2 is derived from this Boolean expression, because that's what we have been talking about. Okay, so the first time, when at this time when you're not actually taking the exam, and you look at statement, say number one, if your reaction to statement number one is, I have never seen this before, I have no idea what this is, I'll be worried. Okay, I'm just going to be super honest, I'll be worried. On the other hand, you go like, I have a vague idea of what this is, but I don't immediately recognize the whole thing. Okay, that's cool. Okay, at least you understand where it's coming from. Or if you look at this and go like, I know exactly how it is derived. I know exactly what's trying to say. I know where it came from. And in fact, I can go back to my own notes and point out, okay, it is right here. Then congratulations, you have been taking notes, absorbing the material as we go. So, nothing is going to become like a really big, it's not a learning curve at this point. It's kind of like running into a wall of, not knowing what we have been talking about. So, not having that sensation is good. So I can also explain just a little bit here. Okay, T of 2 is basically the B of x1, y1, or the B of q1, t1. The B function itself can be expressed as the B of uv, can be expressed as the negation of u and v, and that's why we have T2 expressed in this particular way. And T2 is digit 2 of the quote unquote take row when we have a binary subtraction. Okay, so that is the kind of stuff that I really hope you guys will have in your mind by the time we have this exam next week. So you have another week to prepare, okay? But I want to point out what would be a good state, okay, of your mind by the time you get to the exam. All right. So, but these are all derived for you already. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are all given to you already. Okay. No need to explain any one of those. So the question really starts with number 12. It's like, how do we know that the exclusive OR between D1 and O, which is overflow, is a 0? Okay, so now you have to use all the statements before, find out which one and exactly which one will make this conclusion. Okay, so in the exam, I will not explain what that symbol means because you're supposed to know that. Is that okay? So anything that we have mentioned in the class, in the lecture, or in the reading material, I will not explain those during the exam. It sounds harsh, okay? But that's kind of part of your job to study the material, at least have the knowledge of what the symbols are representing. Okay, are we good so far with that expectation? Okay, so now we go like, okay, fine, let's go back to number 12 and ask you, how do we know that D1 exclusive OR with O is a zero just from 1 to 11? Okay, so the way I would do it is to look for things that mention something about D1 or mention something about O or mention something about the exclusive OR between those two. So the closest one I can find is number 7. Okay, so number 7 seems to be relevant. It says, the L flag is the exclusive OR between D1, which in this case is the most significant bit of the difference, and the overflow flag. Is that surprising you? Is that new to us? It should not be, okay, because we have talked about this in signed comparison. Okay, this is in the binary comparison module when we apply comparison to signed interpretation. Okay, so that's one. And then number 9 is the other one because number 9 says, okay, for no particular reason, I'm telling you that the L flag is a zero. So when you combine 7 and also 9, that would explain why we already know the exclusive OR between D1 and overflow is a zero. So that means the answer to number 12 is really two numbers, which is 7, 9 with a comma in between. All right, so I'm going to actually write this on the side. So this way I'm going to capture the answer as we go. So let me pick mouse pad. There we go. Now this lecture is getting recorded right now, so in case you are going like, okay, I cannot really follow all the reasoning, that's okay. You can go back and revisit the lecture. So this is for Q1, for question number 1, I'm looking at part 12. So part 12 is explained using 7 and 9. There we go. All right, we are moving on to 13. So 13 is saying the exclusive OR between Q0 and T0 is a 1. Okay, so when I look at this, okay, when I look at 13, I immediately think, okay, what is exactly the exclusive OR between Q and T of the same bit column? Ah, that is the difference. D0 is exactly defined this way. So now I would go back to all the previous one and look for the definition of D0, which is number 5. And then I'll ask, okay, how do we know that D0 is a zero? Where does it say that? Oh, number 11. Okay, so between those two, I can now make that conclusion. So I will say 5 and 11 is all we need to explain number 13. Yes, yep, yep, just that. Sorry, you just write the number of the statement. Yep, so that will save you a lot of time instead of writing out the entire thing. Yep. There are some situations like that. So in those situations, I will take alternatives as long as they make sense. Yep. And as you will see that some of these, there are some pretty obvious alternatives. All right, so we are now down to 14. Okay, so 14 is, okay, so I would read the statement first. 14 is about the exclusive OR between Q1, T1. That reminds me of D1 because that's how D1 is defined. Because D1 is the R of Q1, T1, and in the base 2 subtraction, the R function is also just exclusive OR. That's why I look at 14 and I go like, okay, we are looking for, how do we know D1 is a zero? So I would look for the definition of D1, which is number 3, and then I will look for the statement that D1 is indeed a zero, which is 10. Are we doing okay so far? Okay. And now we look at number 15. 15 does not need anything because it says right here, no need to explain. This is already given. So now we move on to number 16. So 16 is a little bit interesting because I look at this and go like, okay, what exactly is this? Hmm, that's actually the OR function. This is exclusive or this is the exclusive OR between Q0 and T0, spelled out the long way. Okay. So now we go like, oh, okay, so that really has something to do with number 13 because 13 is using a single exclusive OR symbol. 16 is just really spelling that out using and or not, okay? But they're really expressing the same thing. So 13 is all I need for 16. All right, moving on to what? 17. Okay, so 17. So 17 says, okay, now we know the overflow is a zero, okay, because of something else. So that means, the first thing I might want to look at is the definition of overflow, which is number 8. Now, it is a candidate, okay, of what we may need, but there are a few other things that also mention lowercase o. One is number 12, right? So number 12 says, okay, we know the exclusive or between D1 and overflow is a zero, but by itself, we cannot fix the value of overflow. The only thing we know from 12 is D1 and overflow are the same. That's all we know because that's the definition of exclusive OR. Okay, so by itself is not enough, but guess what? We also know what is D1. D1 is a zero. It's already given to you in number 10. So between number 10 and number 12, okay, we can make the conclusion that overflow is also a zero. So that's what I'm going to write down before I try to see if you guys have any questions. So number 12 is 1, and then the other one is the fact that we know D1 is a 0, which is 10. So the numbers do not have to be sorted. If you say 12 and then 10, that's perfectly okay, as opposed to 10 and then 12. Do we have any questions about number 17? Why I can make that conclusion for number 17 just because I have 12 and 10? Yes. 7 and 9. Let's take a look. So 7 says the L flag is this. 9 says it is a 0. So the only thing you can guarantee between 7 and 9 is um, the exclusive OR between these two is a 0. That's all you can conclude, which does not address what number 17 is stating. Does that make sense? I mean, are you understanding why what you thought was the answer does not address number 17? Because number 17, I mean, between 7 and 9, the only thing can conclude is the exclusive OR of D1 and overflow is a 0. That's all you can conclude. Yep. Um, So let me give you an extreme version of that, right? So the extreme version of that is, let's say we're trying to answer 17 and somebody gives me an entire list of 1 to 16. So that has to include the one or two of the statements that are actually part of the answer, but you can see how, I cannot really take that as a valid answer. So I guess it depends. I will give you partial credit, okay? So if you're only including one extra thing that has nothing to do with the deduction, I would take like, out of 4 points, I would take one out, take one out. So you get a B equivalence of a B instead of an A. But I won't like go like this is entirely wrong. You get an F. You mean for 17? So for 17, if you say 7 and 10, I will give you maybe half the point at the most, because 7 and 10 together only gets you closer to what we need, but it doesn't really address. Oh, 7, 12, 10. So if you write down 7, 12, and 10, the 7 is not really needed. But the inclusion of that is also like, it's not supposed to be there. So I think I'll still give you a B out of a 3 out of 4. Correct. Make it so that it is bare bone but complete. Yep. Sure. Yeah, absolutely. The reason why I'm kind of, you know, anal about this is because that's what this class is about. That's what computer science is about. Okay, is we want to know exactly what we need, but no more than what we need. Okay, so that's why it is kind of important to kind of make sure that we pare it down to really just what we need. All right, so that's number 17. Now we look at number 18. Number 18 is actually pretty easy because I look at number 18, I look at this formula on this side, and I immediately recognize, oh, that's just how overflow is computed when it is in base 2. Okay, it is the sign of x negated, the sign of y not negated, the sign of the difference, or the sign of x, the negation of the sign of y, and the negation of the sign of d. Because when either one of these conjunctions happen, it means the sign of the difference does not make any sense. That happens if and only if we have an overflow situation. So that part was fully explained in the lecture. So that's why I can see the connection is like, okay, we're looking for overflow. Yes, no, no. The equations will be consistent with the reading material, the way we talk about in class, and also the labs. Yep. All right. So that means in order to answer 18, number 17 is useful, and so is number 8. So between number 8 and number 17, we have a full explanation of 18. So I'm just going to write it down. This is 8, oops, 8 and 17. That's all we need for 18. Yep. 17 alone is not enough because 17 alone does not connect this 0 to this full expression here. So you can only make a connection between the 0 and this entire expression through number 8. Yep. So for number 12, for 17, you put 12 and okay, so let's take a look. Okay, so I'm going to go back and take a look at number 17. So number 17 needs 12. Okay, it also needs um so I put 10, which is here, because those two combined is enough to make a conclusion that O is a 0. So you don't even need to know what is D1 or what is O in this case, because we are saying, the exclusive OR between U and V is a 0. We know U is a 0. We're asking what is V. No, no, that's fine. Yeah, yep. But do you know why 7 is not needed? Yep, yep. Yep. So to answer these questions, there are a few things that are really going to be helpful. One is the truth tables. So the truth tables of what? Well, in this class, we only have 4 truth tables that are actually of any use to us. Well, okay, it depends on a few other things, but I'm going to say 4. Conjunction, disjunction, negation, and exclusive OR. Those are the 4 truth tables that will be really handy. Um, And then the rest are really the definitions that we have been talking about in multi-digit addition and multi-digit subtraction, specifically in this case for base 2. So we convert all the arithmetic operations to logical operations. So this is all based on, base two, operations where all the arithmetic operations got turned into logical operations. Because in this class, this is not discrete math. This is not, computer-based arithmetics. This class is about computer architecture. So what matters to us the most is actually the logical operations. So that's how this particular question is structured, is to make sure that it's my way of assessing whether you understand how base two and how base two addition and or addition is done. Are we good so far? Okay, so knowing the purpose of why this question is the way it is can be helpful too. Okay, because then you can go like, oh, okay, how do I make sure that tech understands that I know what this is about? Okay, so that can also help you kind of reframe how you study as well as how you answer. All right, moving on to number 19. 19 is actually really easy too, because all we need is 18. That's all it needs. Do we have any questions about that? So there are a few things I can imagine going through the minds of people in this class. Some people can look at 19, only depends on 18, and go like, easy. I totally see that in the truth table. Some people may say, but I have no idea why we only need 18 to make a conclusion of 19. Yes, go ahead. No. 18 by itself is already okay. So to a person who does not even understand, who has not taken this class or understand anything about binary subtraction, that person can still make that connection between 18 and 19 without referring to anything else, because this is a truth table thing. So you look up the truth table of OR and you say, okay, we know the result of the OR is false. What can we say about the right hand side of the OR? It has to be a zero. So this one is strictly based on how OR is defined using the truth table. Aha. So now, so I'm trying to explain, all of these little things of how I come to the conclusion. Now, the question is actually generated by a script that I wrote. Okay. But because I wrote a script, I know how it is supposed to work, and I can super honestly tell you guys that I did not vibe code. Just because we have been talking about vibe coding. Some people may be going like, Tech, have you been vibe coding the program to generate questions for us? Nope, these are all completely hand coded stuff in JavaScript. Yes. Yep. So the way I would answer this one is just to put the numbers comma separated right next to each line. Yep. Yeah. Yep. So if you want to have a separate work page or scratch paper, that's fine. If you want to put all the answers on the separate page, that's fine with me too. So as long as I know what answer is corresponding to which question, it'll be fine. You can even move things out of order. I'll try my best to find the answer to a particular question. If you think Yeah, so if you think you might be able to get partial credit because of the scratch paper that you have, you can always attach it. Worst case is, I look at it and go like, no, this is not helping me to give you partial credit. But in the case that I go like, okay, I can see how you are reasoning this out and get to part of the answer, so I'm going to give you some partial credit, then you can get the partial credit, right? So it doesn't hurt. In other words, I don't look at the scratch paper and go like, hmm, this Pokemon picture that you drew of Charmander is really awful. I'm gonna take points off just because of that. Okay, so that's not what I would do. You can draw Pikachu, you can draw Bulbasaur, anything. Yeah. All right. So we move on to number 20. So how do we conclude that y1 is a 1? Okay. So You look at the previous one, which is 19, you go like, oh, maybe it's because of that one. Well, maybe, maybe not. Okay. So now we have to look at the previous one and we say, okay, the conjunction, the entire conjunction of 19 is a zero, right? So you can go like, but if there are many ways for a conjunction of three things to be a zero. So now we look at each one and say, do we have constraints on some of the items of the conjunction already? Do we know anything about x1? Aha, we know about x1 because number 15 says x1 is a 1. So I'm going to just write this down as a scratch thing, okay? So I'm going to write down 15, okay, put a question mark, okay? So in the test, okay, you can just kind of jot down something, and if it doesn't work out, you can just strike it, okay? Don't even bother to erase it, just strike it out, okay? That will save you some time. But I don't know yet, okay? Because I'm really thinking about this as we go, okay? I really do not remember the actual answer to all of these items here. So 50 may be useful, okay? So and also 19 can be useful too. So I'm going to put 19 with a question mark. All right. So at this point, x1 does not contribute to the false because x1 is true. What about D1? Do we know anything about D1? D1 is known to be a zero. So the negation of D1 is going to be a 1, which also means D1 by itself does not contribute to the zero. So I'm going to write that down, which is 10. Okay. Then I go like, oh, wait. Between these three, I now know that Y1 has to be a 1. Because if Y1 was a 0, then the conjunction itself would have been a 1. Is that okay? So that is, that's how I reasoned this one out. So the question marks turn out to be unnecessary because, these are the actual three statements that I need to come to the conclusion that Y1 is in fact a 1. Is that okay? So this one is still dependent on the concept of a truth table, except in this case, the truth table has 8 items in it, but the reasoning is the same. Okay, the reasoning is in order for a conjunction to be a 0, we must have at least one 0 of the three. But then we look at the other two components. X1 is known to be a 1. Okay, D1 is known to be a 0, so that means the negation of D1 is going to be a 1. So of the three components, I know two of them are 1s already, and yet the conjunction is false. So that means the third component, the one that I do not know about, has to be a 0, because otherwise there's no way for the conjunction itself to be a 0. So I know at that point that the negation of Y1 has to be a 0, which also means Y1 itself has to be a 1. Does that make sense? All right. Now we move on to now the nice thing about this type of exam, this type of question is you can leave out some of the really difficult ones and go like, I have no idea, I don't want to waste time to do it, and it's okay because you just lose the point for a particular one, but all the other ones does not depend on the explanation of a previous one. So that gives you the freedom of going like, okay, I'm throwing my hands on this one because I don't want to waste time. I'm going to move on to the next one. You can definitely do that and still get, I would say, a significant amount of partial credit because you don't have to fully explain every single one when you are running out of time. All right. So moving on to number 21, how do we know the exclusive OR between x1 and y1 is a 0? So with this one, we can either know everything about x1, y1, but we don't because we know about we do know x1, y1 by the time we get there. So x1 is a 1, y1 is a 1, so the exclusive OR between those two has to be a 0. Okay, so this is like 15 and 20. That's all we need to know. So 21 depends on 15 and 20. But what about 22? Q1 is a 0. Well, that one is pretty easy. It's because of 21 and also how Q1 is defined as the exclusive OR between x1 and y1. So that would be right here, number 4. So that part, okay, knowing that I need to look for something that looks like number 4 is where your knowledge about multi-digit base 2 subtraction comes in handy. Somebody who does not know anything about binary subtraction will still be able to make that association, but that person will have to really look through all the things to find out, okay, but what am I looking for? But once you understand that, how Q1 is defined using X1, Y1, then you go like, okay, I know straight right away, what I'm looking for. So that's how the familiarity of the content specific to this class is going to be helpful. So what I mean by that is if I give this question to, let's say, Professor Hermione or Professor Kakashan, okay, Salket, they eventually will be able to figure out every single line, okay? But it will take them a long time because they are not familiar with the relationship between the digits, the way that we have been teaching it in this class. Okay, but only using logic alone, using truth tables alone, they will be able to resolve every single line. But it will take them a lot longer. All right, so 23 says we know T1 is a zero. Okay, so we have to look at the two ways to look at T1. This is one way to look at it. Okay, T1 is defined to be number two. So I'm just going to jot down two here and go like, I'm not sure whether it's going to be helpful, but maybe. And then we also want to look at how T2 can be used in some other ways. So T2 is also used combined with excuse me, T1 is also used in combination with Q1 to compute D1. So I'm looking for D1, and see if that is going to be helpful or, yeah. So D1, we know what it is. And do we know the other one? Do we know what is Q1? Oh, we do. Okay, so that's all we need. So once you know what is, okay, so let me just kind of write down here. We know 10, okay, we know Q1, 22. So let's see. So 2 is not useful in that case, okay? We have to get rid of this one because the connection has to do with how D1 is defined using Q1 and T1, which is number 3. All right, so now I go back, okay? In other words, I go to my little parts bin, okay? Pick out some of the parts that I think, okay, I think these things are relevant, okay? But I have to double check, okay, to see how things are actually connected. So number 3 defines D1 to be the exclusive OR between Q1 and T1. And then number 10 is saying that D1 is a zero, which then narrows down the fact that Q1 and T1 must be the same. They can both be ones, they can both be zeros. Okay. And then number 22 says one of them is a zero, so the other one also has to be a zero. So that locks down everything. Is that okay? Yep. Ryan first, and then back to you. Yep. Hmm? 22 and 14. 22 and 14. Yep. Yep. That's actually more direct. Thank you. Yes. Oh, same thing. All right. So you guys are on it, man. Good job. So 22 and 14 is also enough because you can see how 14 itself is 3 and 10. So yeah, so you're correct. Better yet, 14 and 22. So the other one is also correct, but it's not the most concise way to do it, and yet it is not redundant. So there's nothing redundant about 3, 10, and 22. It's just that, well, if you already have 14, why would you bother with 3 and 10? All right, excellent. So we are now moving on to, I'm going to shrink a little bit just so I can see the entire list, because otherwise I'm going to lose the top when I scroll to the bottom. Actually, I might need to do that anyway, so I'm going to do this. And then do this. There we go. All right. So we are now down to 34, 24. There we go. All right. So 24 is the negation of x0 and y0, or the negation of q0, t0 is a zero. So that's basically the definition of T1. So I'm looking at the definition of T1 in this case. So the definition of T1 is 2, okay? And then I have to say, okay, do we know about T1? Well, we do because of 23. So between 2 and 23, we can make a conclusion about 24. Are we good with that? Yep. Uh-huh. And the second one, yes. Yep. It's just the first one is less direct, which means it might take you longer to get to the first option as opposed to the second option. Because I think most people would scan backwards, which means they would get to 14 before they get back to 10 and 3. I just did not do it that way. Is everybody okay with 24? Okay, so now that we are done with 24, we are moving on to 25. And I will try my best to scroll it so that you can see the entire thing. There we go. So we're good there. All right, 25. Okay, how do we come to the conclusion of 25? That's directly from 24. That's all we need. Because if you know the disjunction is a 0, then both sides of the disjunction have to be 0. So that's how 24 directly implies 25. Same thing with 26. So 26 is also directly because of only 24. And now we move on to 27. Okay, so here's 27. So 27 says, Q0 and the negation of T0 has to be a 1. So the question is, how do we know that? So the expression on line of statement 27, this one here, it is the counterpart. This is one of the components of the exclusive OR between Q0 and T0. The exclusive OR between Q0 and T0 is D0. So kind of have to go back to something that mentions those two. Aha, we got 16, okay? 16 mentions a term that is related to the term of line 27. So I'm just going to write down 16 as a potential, okay? So we'll write down 16 and put a question mark here. So 16 alone is telling us the OR between two things is a 1, which does not lock down anything. Okay, the only thing it tells us is at least one of those two sides is a 1, but it doesn't tell us anything about which side has to be a 1. So the only way you can lock down one side has to be a particular one is the 1 is to say the other side is a 0. Okay, so because the conclusion of line 27 is this one is a 1, so that means we are looking for the negation of Q0 and T0 is a 0, which is 25. So 25 is what we need in conjunction with 16 to come to the conclusion of 27. Yep, 25, 25, 5, 11. Okay, let's take a look. So we are still using 25, okay, but then we use 5 and 11. So 5 is right here, 11 is here. Okay, so we know the exclusive or between these two is a 1. That would not be enough. It's not enough. And I can explain. So if you look at only 5 and what was it again? 5 and 11. So between 5 and 11, the only conclusion is Q0 and T0 are different. One is a 1, the other one is a 0, but not necessarily in this way. 13, you still need that connection to this particular conjunction. And the only way to make a connection to this conjunction is either 24. So 20, so 24 does not hook up to this one. 24 hooks up to the opposite of this one, so it's not useful to us. 25 does, okay? So 25 hooks up with 16 to directly lead to that conclusion. Okay. Yeah, yeah, sure. If you can think of alternative ways to explain things, and you're not really sure whether I would take that as an answer, you can always contact me after class, okay, or before class, because my office hour is immediately before this class, so you guys can just kind of come a little bit early and talk to me, so I can confirm one way or the other whether your way of answering this question is going to count or not. But are we doing okay so far with the alternative? Okay. All right, we're moving on to 28. So 28 says Q0 is a 1. That's because of 27 itself. Because if the only way for conjunction to be true is both sides are true. So 27 being a 1 means 28 also has to be a 1. So now we move on to 29. We're almost done here. So 29 can either be because we already know what is x0 and y0, but we don't know y0 yet because y0 is on number 33 and we're not there yet. So we cannot use the definition of um, x0 and y0. So instead, we have to use something else. X0 exclusive OR with Y0 is also known as Q0. Okay, so now we want to go back and say, do we know anything about Q0? Q0 is already known because of the previous one. Okay, cool. So then we just have to hook up Q0. So I'm going to write down some here. Okay, so 28 seems to be useful. We also know X. Oh, wait, that may not be helpful. Huh? 6. Yep, 6 is all we need. So 6 and 28 together. Thank you. All right. So that would explain why we know the exclusive OR between x0 and y0 is a 1. And then 30 is only because of 29, because 30 is the other way to write exclusive OR between x0 and y0. So those two are just like that. And then now we move on to 31. Okay, 31 is something that we have seen already. It is only because of 30. And then we move on to 32. 32 says, how do we know T0 is a 0? So there are two ways to do it. One is to look at the um, D0. Okay, if D0 is known, Q0 is known, then we can make that conclusion. And turns out we already know both of those. So D0 is number 11. Um, Q0 is 28, and the way they are connected is the definition of D0 using T0 and Q0. So that would be number 5 again. There we go. Are we doing okay so far? All right. So we're almost done. Two more. Okay. So now we have 33. So 33 is saying, how do we know Y0 is a 0? That has to do with um, we cannot use 31 directly, okay? So 31 cannot be used here because 31 does not know anything about x0. So that means, oh, wait. We can, sorry. That was my bad, my bad. It was indeed 31 because 31 says the conjunction is a 1, which means both sides of the conjunction all both have to be a 1. But in order for the negation of y0 to be a 1, y0 itself must be a 0. And then number 34 is the same way. So number 34 is also directly because of 31. Whew, done. So I have actually tried this one on ChatGPT, and I gave ChatGPT the full definition of all the symbols and how multi-digit subtraction in base 2 works. It got, I think it probably missed maybe 4 or 5 of these, okay, but it got the rest. So I was actually somewhat impressed, okay, because ChatGPT is an LLM. It's not a logic engine, not by any means. Yes, for number 26 and for number 26. So for number 31, 26. You mean this one? Um, Not directly, because knowing that the conjunction of the negation of x0 and y0 is a 0 does not guarantee that this one is a 1. So you're saying number 30 does not directly explain number 31? They do. It does. Because number 30 sets the um oh, okay. So what did I use? You're correct. Okay, you are correct. So we also need 26. You're correct. Thank you. So we also need 26 in this case because it rules out the other one. Okay, thank you. Yep. For 34, do we need what else again? 33? No, we do not, because in this case, it is the result of a conjunction. And in order for conjunction to be true, both sides have to be true. In other words, one single statement that the conjunction is true locks down that the left-hand side is true and the right-hand side is true. But what the other student was pointing out had to do with what's your name? Cody. So what Cody pointed out was a different thing because in order for a OR to be a one, only at least one side has to be a one, or both sides can be one. And then if only one side is a one, I don't know which side has to be the one that is a one. So that's why I need number 26 to help me lock down and go like, oh, since one side is a zero already, so the other side has to be a one in order for the disjunction to be a one. So it depends on what result, what operation. It depends on those things to see what you can lock down with one single statement. Sometimes you cannot, and you have to rely on something else to help you rule out the other possibility. Yep, 29 for 31. Okay, so 31 using 29 and 26. Not directly because this the exclusive OR has to be expanded into this form before we can get to the other component. That's the only reason. Yep, yep, yep. Because it's if you only use 26, 29 to arrive to 31, the misconnection is what does 26 and 31 have to do with 29? Yep. The 30 is the bridge to basically spell out and say, oh, okay, the exclusive OR is really this. Yep. All right. So that's number one. And shall we move on? All right. So as we work on these, the question that you might need to ask in your head, in your mind, is how do I prepare? How do I study to be prepared for the exam? Okay, because you got a week to do it. Okay, so that's quite a bit of time. All right. Question number two is mostly about knowledge. It has very little to do with problem solving. Number one is a lot of problem solving. Okay, you have to make connections and deduce and blah 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 and stuff like that. Number two is like if you study, if you read the material, if you have been taking notes, it's like why do we even have this question? Okay, so we'll start with part one of question number two. What is VSX7? In other words, what is the value? Okay, figure out the value of VSX7 for me. Okay, now, VSX7 sounds like another child of Elon Musk. All right, how do you approach this question? If someone walks up to me during the exam and asks me what is VSX of 7, I'm not going to answer that question. Okay, I will refrain from using any expression on my own face to express what I think of that question, but I will not answer that question. Okay, because how many times have we talked about V as a bit pattern and then a number? I can go back to the transcript of my videos and actually ask ChatGPT count the number of times this function was explained. Okay, so we just have to go back to the definition and find out how it is defined. So just to encourage people in this class to study, I am not showing you the actual function, but I will show you the answer. So this is for question number 2, part 1. That would be 1 plus 8 plus 32. So that's 41. So I'm going to say VS X7 is 41. If you know exactly what I was just talking about, great. If you don't, it is time for you to study a little bit. Okay? At least figure out where you find that definition. Number 2, okay, part 2. What is VU of the same thing? Okay, this has to be the twin of the first child. So Elon Musk, has a twin. One is VUX7, the other one is one is VSX7, and the other one is VUX7. So that's actually boiling down to the same thing, okay? But the reason is something that you should probably go figure out. All right. My job here is to give you guys the knowledge. That is done by the reading material. Okay. So I would appreciate people to put in their own effort, to read the reading material and then figure out, oh, okay, I can plug that in. Done. All right. So number 3, what is C2 of X as a bit pattern, as a base 2 number? Okay. Show all your steps to figure out the answer. Okay. So what is C2? What is it representing? So once again, this is a knowledge question, okay, because the symbol or the definition of C2 has been introduced. It is in the reading material. We even have a lab, okay, connected to V2, C2 of something. So you kind of have to study a little bit, okay? Make sure you get all the definitions right, okay? So once again, to encourage people to do their studying, I'm not gonna say anything. I'm just gonna say C2 of X is actually as a base 2 number. I have to do this mentally, which is a little bit of a strain, but that's okay. I can do it. Uh, there we go. That's the bit pattern corresponding to C2, which is also known as, I'll give you a clue, okay? It is two's complement. Okay, so look it up. Okay, what is the two's complement of something? All right, so number 4 is asking what is the VS of the answer of part 3, comma 7. So that is, okay, so C2 of, oops, wait, VS of C2 of X7 is negative 41. So once again, these answers, if people just give me these answers in the exam, they will get at best 25% of all the points because there are no steps shown to show me that that person know what that person is doing. All right, so I just want to emphasize that this is not the ideal answer, but I'm giving people this class the unideal answer because if you are thinking, I have no idea how the answer become the answer, you need to study a little bit, okay? Just studying alone is going to be able to answer these questions. All right, number 5. Consider a 7-bit binary addition of x plus y, okay? So one of the questions that people might be asking is signed or unsigned? So my answer to that question is something that I have used already in a previous class. What do you care? Because the addition mechanism does not care about the interpretation of the bit patterns. It is still exactly the same, okay? So now the question is really asking, what is the bit pattern y so that VUY7 is the least value that results in K7 being a 1. Show your steps to figure out the bit pattern. Okay, so the first thing you need to figure out is what the heck is K7? What is K7 in a 7-bit addition? Hmm? Go ahead. The overall carry of the entire addition, right? So why would the overall carry be a 1? What is the job of a carry? Go ahead. That's one way. Okay, so x6, y6 both being 1, or q6, t6 also being 1s. But the bottom line is the overall carry of an addition tells you that the sum, using only 7 bits in this case, is not enough to represent the sum. It is too much. Okay, but only in the unsigned perspective. Okay, in other words, I want to trip K7 to be a 1, but just barely, because the question says I need VU of Y7 to be the least value, resulting in this condition to happen. So that means I'm really looking at a value, I'm looking at a bit pattern Y, so that when I add X and Y together, it just barely trips the overall carry. So when you barely trip the overall carry, that means the sum itself is going to be all zeros, because otherwise you're not just barely tripping the carry, you're having more. So that means the actual result of the addition is having K0 being a 1, but all the sum bits will be zeros. Okay? So what value is that representing? Okay? All the sum bits being 0 means the sum is actually 0 itself. But K7 being a 1 means what? What is the value of K7 being a 1? It is digit 7 of something. So whenever digit 7 is a 1 in a binary number, what quantity is it representing? It is 1 of what? It has to do with the position, right? So in the base conversion discussion, digit 7 being a 1 means we have 1 of what? We have 1 of whatever base we're dealing with to the power of 7. Okay, so it'd be 128 in this case. Okay, so that means we are looking at a value of y or a bit pattern y, so that VUX7, which we already know is 41, plus that whatever VUY7 is supposed to be, we need that to be 128. So does that help you find the VU of Y7? Okay, so I'm just going to write down here. Okay, so VU Y7 needs to be 128 minus 41, which is what? 87. So that means, but the question is asking what is Y. This is not Y. This is telling you if you interpret Y as a 7-bit unsigned integer, it will give you 87. So I need to go back and figure out what Y is. So Y in this case would be 1 of 64, none of 32, 1 of 16, I think. That would take care of the 80. And then we have uh, none of 8, and then 1 of 4, 1 of 2, and 1 of 1. So that would be the bit pattern. Once again, I'm not showing you the steps because it is important for you guys to try to figure out the steps to do this. Because that part is base conversion. That's what base conversion is about. Are we still doing okay so far? Okay. So if you guys absolutely need me to fill in the gaps by Wednesday, I can probably do that. But I would really like you guys to be at least reading into the reading material so that you know what the answer is. Okay? It is not my job to study for you. here, there. I think that's as plain as I can put it. All right, number 6. Kind of the same thing, except this time we have a subtraction, and we want the overflow to be a 1 after we have this binary subtraction. And I want z as a bit pattern, so the vs z7 is the largest value that results in the overflow being a 1. Okay, so how do you approach a problem like this? Well, you go back to what is the overflow? What does it mean when overflow is a 1? So you can look at it from two different perspectives. One is from the bitwise perspective, which is what question 1 is all about, right? One is from the meaning perspective, okay? What does it mean when overflow is a 1? So go back to the examples that we have talked about in this class. What does it mean when overflow is a 1? We have explored that in the lectures, okay? So you kind of have to go back and try to say, okay, do I remember that, okay? If you don't remember, you have to be able to find the notes for that particular day and be able to read it and go like, oh, so that is what it means. But I'll give you the answer anyway. Overflow means the when you look at the signed subtraction or okay, so overflow in this case, okay, I'll even write it down so that you guys can have it if you want to, if you think this is important enough, okay? So overflow is a 1 if and only if vs x, whatever the width is, minus vs y, whatever the width is exceeds the range of values, of signed values that can be represented in W bits. That is what overflow is. I believe we talked about this already, okay? But maybe it didn't quite sink in at the time. So the question here is really just kind of making sure that it did sink in, when we talked about this. So, okay, this is helpful, but it is not really useful unless you know how to find out the range of signed integer representations, right? So did we talk about that? Yes, we did. The reading material actually includes that too. So once again, this part is reliant on you reading the reading material or your notes and go back and go like, oh, okay, so what exactly is the range of values that we can represent using 7 bits in this case? So without quoting the expression itself, I can tell you that we can represent from negative 64 to 63 with 7 bits. Okay, so that means I need to somehow exceed this range by a subtraction of some kind of value, which is vs z7 from vs x7. Vs x7, we know already earlier that it is 41. So we are looking at an equation that looks kind of like this. 41 minus vs, this is z, 7 is exceeding the range, okay? So we need this to exceed negative 64 to positive 63. Okay, so tell me how we can do this. First of all, are we going to try to exceed it on the negative side, or are we going to try to exceed it from the positive side? What do you think? So we know that, okay, let me make this a little bit more clear. This is poor penmanship. Z7. Now, VSZ7 has to play by these rules too. So we are looking at, hey, if I subtract 63 from 41, it will be a negative number, but is it going to exceed the range? No, 41 minus 63 is what, negative 22? Negative 22 is well within this range. So we cannot overflow on the negative side. Can we overflow on the positive side? So to exceed from the positive side, we have to subtract a negative amount from a positive amount so that the result is exceeding 63. Can we make that happen? So what is the first value of exceeding? Is, oh, okay, if this thing is 64, then we have an overflow because 64 itself cannot be represented as a 7-bit signed integer. Is that okay? Does everybody understand how I come up with the 64 on this side? That was just algebra. So what is this quantity when we know this is 41 and this is 64? Okay, so we are looking at V as Z7 to be 41 minus 64, which is negative 23. Okay, but the question is not asking about V as Z7, it is asking about Z as a bit pattern. So now the question is, what bit pattern Z will give you the VS interpretation to be negative 23? So what is the first thing that you need to know to answer that particular question? The definition of VS. Okay, so once you look at the definition of VS, then you go like, oh, okay, so negative 23 needs to be expressed as negative 64 plus something, plus some powers of 2 in order to make it 23, negative 23. So it looks like we're going to need a 32 here. And then after that, we have negative 32. So negative 32 to get to negative 23 is going to need an 8. That will bump it all the way up to negative 24. So we need an extra one here. Is that okay? So now the next question is, okay, some of you may have this question of why do we look at a summation like this? What do you think? Where is this coming from? The very definition of VS. Okay? And I keep keeping you guys in the dark of not telling you what VS is because once again, I want you to find it. Okay? And try to read it and understand what it is. Then you can actually associate why I have a negation or arithmetic negation of 64, but the rest of the powers of 2 are not negated. They are just added together. Okay, but from this, I can now say, oh, I know what the bit pattern is. I have 1 of 1, none of 2, none of 4, 1 of 8, none of 16, 1 of 32, and also 1 of negative 64. So now, this is my answer. Z is this particular bit pattern. Okay, but everything in question number 2 hinges on the definition of VS. Okay, which is the interpretation of a bit pattern in the signed way. So that's important. Okay. All right. Moving on. We are not going to have a lab today, so we are going to use the entire class to talk about the exam. Okay, so here we move on to question number 3. So question number 3 is, okay, I'm going to bump this up again. There we go. So number 3 is about base conversion. I mean, it's about base conversion, but it's also about performing multi-digit addition in this case in base 7. All right. So for this one, I'm just going to briefly describe, number 1, part 1 and part 2, but I'm not going to give you the answer because, that should be pretty obvious. So for number 1, what is the decimal representation of the value represented by the y row? So the y row is 553. So the base 10 representation is going to be 5 times. Okay, let me highlight which 5 we are talking about. What is this 5 talking about? What is represented by this 5? It is a quantity, but you have to multiply what to this 5 as a part of the value that we are representing. Nope. It is, okay, we're dealing with base 7 numbers. So we're dealing with a base 7 number. So what is this 5 trying to convey? We have 5 of 49. That's right, because it is digit 2. So that's why the 5 is representing the quantity of whatever base, which is 7 in this case, to the power of the position of the digit, which is 2. We good? So if we know this 5 is the quantity of 7 to the power of 2 or squared, what is this 5? It's the quantity of 7 to the power of 1 and then plus 3 times 7 to the power of 0. So that summation is going to be the answer of part 1. You can bring a calculator if you don't want to waste too much time on, you know, these type of calculation. Okay, number 2. Number 2 in this particular exam are essentially 3 points. Okay, because it's really just asking you about, oh, tell me how C of UW is defined when we're dealing with a base 7 number. So all you have to do is to find what is C of UV for base 10, change that 10 to a 7, you're done. Okay, and then number 2 is asking you about the same thing, but it is about R of UV. I did not use V itself because V is used to somewhere else that has significance, so that's why I'm not using V. But R of UW is defined already in base 10. So you take the base 10 definition of R of UW, change the 10 to a 7, and you're done. And then they ask you about S of I, Q of I, K of I plus 1. Those three they don't even depend on what base we are talking about. Okay, the relationship between the digits of S of I, Q of I, and K of I plus 1, they don't even care about what base we are talking about because we'll be using the C function and the R function to define the relationship between the bits. So once again, this is a straight up knowledge question. Do you know the definition of those digits? I'll give you a clue. These are all introduced in the binary addition subtraction module. Okay, so as you read through that reading module or reading content, you will find these definitions. So now we move on to part number 3. So we have to kind of fill in the blanks. Okay, so we'll go ahead and fill in some of those blanks. Okay, so I think one way to do it is just to do it on the whiteboard. Okay, so that's what we'll do. All right. All right, so we're gonna figure out, all of these unknown digits that have underscores. So now the question is, what plus 3 equals to 6 in base 7? So the reason why we have those earlier question is because this is saying that we know that R of something, okay, R of x3 is a 6 in base 7. How do we solve for this x? Which goes back to, oh, you kind of have to know what R is, okay, as a function. Okay, so instead of telling you what R is, spoiling all the fun, I'm just going to say the answer is a 3 here. Okay, 3 plus 3 is a 6. 6 plus 0 is also a 6 in base 7. The next column is a little bit more interesting because we are asking what plus 5 is 0 as a single digit sum. In other words, I'm asking you what is R of x comma 5 is a 0 in base 7. That's what it's asking. So once again, okay, knowing what R is the key to answer this question. Okay, so instead of telling you what R is, I'm just going to tell you, okay, if you use a 2 here, then you end up with a 0 here. But at the same time, you also have to remember how k of I plus 1 is defined. So according to how I of k plus 1 is defined, this will give you a 1 over here automatically. And then this is going to be a 0 because this is how k of I plus 1 is defined using the C function as well as xi, yi, qi, ki. So all of those equations are important, okay? And this is an application of all of those functions. It is not a tricky kind of question where you need to do a lot of deduction. It really is just application of what we have learned regarding the definitions. All right, so now we need to figure out what plus 5 is a 1 in base 7. It's a 3. We end up with a 1 here, and then we have a 1 plus 1, which is a 2 here. So that would be the answer. I didn't quite show you exactly how I arrived to each one of those digits because they depend on the C function, the R function, and how the digits relate to each other. Okay, and all of those are in the reading material as well as in the lectures. So I'm trying to force you guys to study by giving you something, but not everything. I mean, who wants to go watch a movie when you already know exactly what's going on in the movie? That spoils the fun. Not a whole lot, actually. Surprisingly, not a whole lot. I do only watch certain parts of Star Wars, so certain lines of Darth Vader kind of really stood out to me, like most impressive. hmm Yep. hmm So in part three, okay, which is just filling in these, you don't need to show your work. But you do need to show me the definition of R and C and also the relationship between the digits in the previous part. Because once you fill that up, number three, the next part is kind of like pretty direct. But you do have to explain. So when I ask for an explanation, then you have to show me the steps. All right, so we're moving on to part four, which is the last part of question number three. So with that one, it is, I mean, whew, wait, wait, 206. Because it's 206, so you have 2 times 49 plus 0 times 7 plus 6 times 1. There we go. Yep. So this question is about base conversion. It is about, multi-digit addition in a not binary base. Okay, so that means you cannot use logical operations. So you have to go all the way back to how C and R are defined, and also how the S of I is defined, how K of I plus one is defined, and also how Q of I is defined. So those definitions become important for question number three. Are we good so far? And everything is only with respect to the exam from last semester. There's no guarantee in whatever way what kind of question you'll be getting, because I still do not know how I want to ask those questions. But you can be guaranteed about the scope of what I'll be asking. Okay, I'll be asking about binary addition, binary subtraction, binary comparison, signed versus unsigned representation, base conversion, okay? Base conversion in the sense of converting from base whatever to base 10, and also the other way back, okay? Base 10 to whatever base I want you to convert it back to. So the next one is about double. So this one, I give you a binary number to begin with, okay? The binary number is already expressed as a quote unquote scientific notation in base 2. And I also give you VD, okay? So this time I actually gave you the full definition because that is actually all you need, okay? You don't need anything else. I mean, if I give this question as it is to someone who can work with math, that person can figure out every single part of this question, okay? It might take a little longer, okay? But that person should be able to work this out. So 25, okay, well, not 25, part one, step by step show the value of z represented by a base 10 decimal number. Okay, so you look at how z is defined here, and you just have to evaluate this and give me the base 10 representation. But I want you to do it step by step. So the only way or the only part that you have to do step by step is to say, oh, okay, look at this binary number here. Let me show you what this looks like as a base 10 thing. That's the only part where there's actually any work, because the other part, which is looking at 2 to the power of 5, you can just say, oh, that's 32. Okay, so there's no work involved with 2 to the power of 5, but there's work involved to convert this into a base 10 number. Now, personally, if I were to do it by hand, I would not even do that. I would basically shift the binary point by 5 places to the right-hand side, convert that to a base 10 number, because that way I only have to work all the way down to a quarter, which I can easily do by hand. Anything beyond 1/8 is a little bit harder because it's 0.0675 or something like that. So it's not easy to work by hand. All right. So part one is going to be just a base 10 representation of this, which is let me see if I can give you a quick calculation. All right, so we'll give that a try. Okay. BC is kind of like a command line calculator that I use. So in this case, I'll be saying that so after we shift all the points, then we end up with this decimal point all the way to here, because I'll be moving the decimal point by 5 digits, and then we don't have a power of 2 anymore in that case. All right, so then we have a quarter, 0.25, plus, okay, I'm going back here. We have none of 1, none of 2, 1 of 4. So we have a 4, no 8, a 16, and also a 32. So the answer would be 52.25. Okay. But instead of just writing down the answer, you probably want to figure out why I can convert this number to this particular format. I'll be seeing how I did that. Okay. I did it by moving the binary point 5 digits over. So it becomes 110100.01 in base 2. And then I just add up the powers of 2 corresponding to each digit position. And that should add up to 52.25. Are we doing okay so far? Okay. So we still have Wednesday, as another day before your exam on Thursday, before your exam on next Tuesday. So if there's something that you absolutely cannot figure out by Thursday, I can kind of give you guys more hints. Okay. But I think, you can work that out, given that I'm dropping quite a bit of hints today. All right. So number 2, compute the biased exponent of 2 and represent it as a base 10 number g and explain your answer. So the actual power of 2 is 5, okay? Because this is the 5, this is the mantissa. So the 5 is the actual exponent that we want. What is the bias amount in the IEEE double precision floating point number format for the exponent? What is the bias amount? 1023, exactly. Now, why they chose 1023, I don't know. Okay. It's approximately half, right? So why 1023 and not 1024, right? So that is the part I don't get. So it's 1023. So the biased amount is going to be the 5 plus 1023, which is 1028. So 1028 would be the answer of part 2. Part 3 is base conversion. What is 1028? What does it look like as an 11-bit binary number? That's base conversion. So that would be 1 followed by 7 zeros, and then a 1, and then 2 more zeros. Why? Because 1028 is 1024 plus 4. 1024 itself is 2 to the power of 10. 4 is 2 to the power of 2. So that means the digits, digit 2 and digit 10, would be ones when everything else are zeros. So that's how I did the base conversion in my head, but you have to show your work. Are we good so far with that base conversion? Okay. And then moving on to part 4, assemble all these bits, so that we have uh, the bit pattern X, so that VDX equals to Z. Explain where the bits come from, and then you can use the 0 dot dot 0 notation, but indicate the number of zeros. All right, so I will do this on the whiteboard because that's the easiest way to do it. Okay, and everything that you need to know about to get to the answer is actually here. Okay, the VD definition is basically all you need. Everything else is really just a derivation, or it is deduced from the definition of VD. So for number 4, okay, we have to first think about, okay, what is x of 63? What is the role of x of 63? How is it used? It's the sign bit, right? So do we have a non-negative or a negative number for z? Is z non-negative or negative? It is non-negative, which means x63 should be 0. Very good. So we start with 0 as the most significant bit. The next 11 bits would be the biased exponent. How do I know that? Because of this part. I goes from 52 to 62. So those are the bits that are responsible to add up to the biased exponent. But we already figure out the bit pattern for the biased exponent. So that would be 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. A 1 for the 4, 2 more zeros. Okay, so we'll double check, make sure there are 11 digits here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, perfect. And what about the rest? Okay, the rest would be the bits that are specified here. These x of I would be corresponding to the rest of the bits, but we talked about this already. That portion is the fractional part of the mantissa. The mantissa is already here. This is the entire mantissa. But I don't need the entire part of the mantissa. I just need the fractional part of it. So I'm just copy and pasting this portion over. So that would be 1, 0, 1, 0, 0, 0, 1, and then the rest are all zeros. Okay, exactly how many zeros is in here? So we have to do some counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So out of 64 bits, I have 19 of them specified, which means this portion would be 64 minus 19, which is what, 45? Okay, so there are 45 zeros after this one. So that would be the 64-bit pattern to answer part number 4. So part number 5, okay, so this is for part number 4. So part number 5 says, okay, I want to look at this as a base 16 number, which is hexadecimal. How do we convert a bit pattern into hexadecimal representation? Yes, there's a table to do this. So you basically group the bits by 4, okay, one chunk, one chunk, one chunk, one chunk, one chunk, and the rest would be chunks, okay? So this would be a 4, 0, 4, A, 2, and then a bunch of zeros. And since in base 16 you need 16 hexadecimal digits to make up for 64 bits, so that means we have 11 zeros after the 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Done. So that would be the answer to question number 5, or part 5 of question number 4. That's it. That's the whole test. You guys are going like, but Tech, you used 1 hour. No, more than that, right? We used 1 hour and 40 minutes to answer the entire thing. But that's because I kept taunting you, right? Yes, I would use that word. I kept taunting you guys and go like, okay, this is something that you're supposed to know already. And this is where you can find it, and so on. So without those, kind of remarks and whatnot, it would have been taken a lot less time. All right. So knowing that this is the test from spring 2025, how are you going to prepare for your own exam one that is next Tuesday? So that really is the big question. How are you going to do it? What is important? Hmm. If I just print everything that Tech has from the Canvas site, I think that should be enough. Yes, go ahead. Yep, make your own notes. And the way you make your own notes, I have some suggestions. You may or may not want to use my suggestion. Put all the definitions to one place. Okay, you have one single page that has no explanation, no reason why we derive it the way that it is. This is just the definition. Okay, so VS, VU, VD, okay, those are some. The R and the C, the R and the B, okay, the relationship between all the digits in a multi-digit addition and a multi-digit subtraction, how L is defined, how overflow is defined, how exclusive OR is defined using and or not, all of those are definitions. Okay, so make sure you have all the definitions down. Going over this test, okay, is already giving you somewhat of an inventory of the definitions that you need. There are two more, okay? One has to do with converting a number from whatever base to base 10, the other one to go back, okay? I give you a base 10 number and I ask you, okay, how do we represent this using base 4 or base 5? Okay, so all of those are super important because as you go over those definitions, and you go over this test, you will start to make connections of, oh, okay, so that is how VS is applied to answer a particular part of question number three. Okay, so until you do that, none of this is going to make any sense because you are not making the connections. You cannot make connections when you don't have the waypoints. You need to at least establish the waypoints first on the map before you can figure out, oh, okay, to get from this waypoint to this waypoint, the best way is doing this. But you need all of those waypoints first. And the waypoints are in the form of definitions, symbols, and equations. Is that okay? So that's how I see, how what the content is. And in the class, okay, in the exam, all I'm really asking is, okay, we are starting from here on the map, and I need to go over here. If you know all the waypoints in between already, you're just navigating from one waypoint to another waypoint to another waypoint. But if you don't know the waypoints, then you're going like, I have no idea to go from A to B because I don't know all the intermediate waypoints. So that's why the waypoints are important. All right, so I think I have yacked long enough, and you guys can ask questions if you want to. You can also, if you want to tell me your comments for this class, you can do so. If not, you can also, do whatever post you want at, ratemyprofessors.com, as if I'm going to read that. Huh? Floating point numbers? What about it? Yeah. Did I say that won't be on the scope? Okay, so since I said to this class, floating point number is not going to be in exam one, so that's I'm taking it off of the first exam, so but it will be in the second exam. So now I have to think about something else to ask. That's okay, I honor whatever I said. So if I said floating points won't be in the exam, won't be in exam one, I will take it out. There's plenty of other things I can ask. All right. Any other questions? You have 1 week to get ready. Okay. I have office hours every morning from 8 to 9, including Fridays. Okay, so if you ever run into problems like, I don't know what to make of this statement in the reading material, I'll be more than happy to explain that, especially if you ask, ChatGPT and ChatGPT goes like, I have no idea what this means too, okay? Which it never will do because ChatGPT is always going to confidently tell you something which may not be right. So use my office hour, okay? Read the reading material. Go back to the video recording, okay? Because I'm pretty sure I explained everything with examples in the lectures. So go through those. Um, does it mean that you have to spend time now? Yeah, I'm afraid you kind of have to make use of those 2 extra hours for every hour in lecture. All right. Well, I don't have anything else to add. I can stop the recording now unless you guys have specific questions about the content of today's class. Nope. All right. So I'm going to stop the recorder, and we don't have a lab today.